This video is an introduction to sine, cos, and tan, and something that I'll be using a lot over the next few weeks. But this video just introduces you to it, recaps it from junior cycle, and goes through a few examples of the types of questions that you'll be asked. So on page 16 in the form and tables booklet, you'll see the following. So you have a triangle. In that triangle, you have a particular angle, and that angle is called A. You've also been given three sides. We've been given A, B, and C. Then what they say is that the sine of A is equal to A over C, the cos of A is equal to B over C, and tan of A is equal to A over B. So this is actually quite confusing, and it's difficult to know what they actually mean by this. And some of the questions don't actually label the right sides of the right angle triangle with the letters A, B, and C, making the use of the formula on page 16 quite difficult. However, it is much easier to remember and understand kind of this. So if we say the sine of A is equal to the opposite over the hypotenuse, cos of A is equal to the adjacent over the hypotenuse, and tan of A is equal to the opposite over the adjacent. And I'm sure the way that you remember it and the way you talked about it from junior cycle is SOHCAHTOA. Now, if we go back up to the triangle here, we're able to label them. So we have the angle A. To label the side opposite angle A, you just draw a line from A in the direction away from it, and it's whatever side you touch first. So A here is the opposite, and we usually label that OPP. The hypotenuse is the longest side, and the longest side is always opposite the right angle. So this side here is the hypotenuse, and we usually label that as HYP. And then the last remaining side is what we call the adjacent. So the best way to figure out how to do this is go through a few examples. To recap what we said on the last slide, so to use the formula, you have to know how to label the sides of a triangle. So the hypotenuse is the side across from the right angle, the opposite is the side across from the angle we are using, and the adjacent is the other side. So just to have a look at the two triangles here, we have the first triangle and we have angle A. The side that's opposite angle A, I can draw a line to here. The hypotenuse is opposite the right angle, which is this side here, and then the adjacent side is the side that's left. In the second triangle, we have the angle B, and the side that's opposite B is the one that's labeled opposite there. The hypotenuse is the one that's opposite the right angle, and the adjacent then is the remaining one. So you should always label the sides of your triangle. It's really, really important. And when labeling the sides, we can use the nicknames HYP, OPP, and ADJ. Don't use HOA because the letter H often gets mixed up with height, and that's one thing people do in the exam the entire time. So please use HYP, OPP, and ADJ. So question 3.1, it says write down sine, cos, and tan of the angles marked A. The best thing to do for this is, first of all, write out SOHCAHTOA. We know that sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. What we can do is we can start labeling the sides of this triangle. So as we said, the opposite is always going to be directly across from the angle. So we have the angle A, so then 3 here is the opposite. The hypotenuse then is always opposite the right angle. So this is the hypotenuse. And then the remaining side is the adjacent. So I'm going to write it out. So the sine of A is equal to opposite over hypotenuse. The cos of A is equal to the adjacent over the hypotenuse. And the tan of A is equal to the opposite over the adjacent. We can fill that in then, so we'll get the sine of A is equal to the opposite, which is 3, over the hypotenuse, which is 5. The cos of A is equal to the adjacent, which is 4, over the hypotenuse, which is 5. And the tan of A is the opposite, which is 3, over the adjacent, which is 4. And that's that question done. So in many questions, you could be asked just to write down what sine, cos, and tan, what they stand for, and that should be hopefully easy enough once you have labeled the sides OPP, ADJ, and HYP, remembering that the opposite is always directly across from the angle, the hypotenuse is always directly across from the right angle, and then the final one is the adjacent. In many questions, we can be given sine, cos, or tan and told what that's equal to, and then asked to figure out what the other one might be, so either cos, tan, or sine. And there's 5 steps of how to do this. So the first step is to sketch a right angle triangle. Step 2 is to label the angles given. Step 3 is to label the 2 sides given. Step 4 is to find the missing side using Pythagoras' theorem. And step 5 is to fill out the answer. Now, this is best explained with an example. So question 3.2 says, if sine of x is equal to the square root of 7 over 4, find the value of cos of x. So the first thing we do is we just write out a right angle triangle. It can be any right angle triangle, it doesn't really matter. So we have here that the angle is x. So the angle opposite x is what we label the opposite. Opposite the right angle is the hypotenuse, and the remaining side is the adjacent. Now, we know SOHCAHTOA, and we also know here that sine of x is equal to the square root of 7 over 4. So in this one, we have sine, and we know the sine of x is equal to the opposite over the hypotenuse. The opposite here then is square root 7, and the hypotenuse is 4. So then what we need to figure out is we need to figure out the cos of x. And the cos of x is the adjacent over the hypotenuse. We know what the hypotenuse is, that's 4, but we don't know what the adjacent is, so we have to figure that out, and we can figure that out using Pythagoras' theorem. So we have here c squared is equal to a squared plus b squared. So c is the hypotenuse, which we know is 4, so 4 squared is equal to a squared, which will have square root 7, and then b squared, which is the adjacent, which I might label y, plus y squared. So then we'll get 16 is equal to 7 plus y squared. Can take 7 from both sides, so we'll get 9 is equal to y squared. So then y is going to be equal to 3. So then the adjacent is 3. So then the cos of x is equal to 3 over 4. And that's the answer for this question. Question 3.3 is very similar. So it says, given that tan of a is equal to 4, write cos of a in the form 1 over square root x. So here we have the tan of a is equal to 4. Now, that's the same as writing the tan of a is equal to 4 over. So again, we can just write out SOHCAHTOA. And we know that the tan of a is the opposite over the adjacent. So drawing out a triangle for that, we have the right angle here, and we have the angle A. So the side opposite A is the opposite side, and we can see it here. Then the side opposite the right angle is what we call the hypotenuse, which we can see here. And then the final side is the adjacent. Filling in what we know that the opposite is 4 and the adjacent is 1. So the adjacent is 1, the opposite is 4. We then need to find cos of A, and cos of A is equal to the adjacent over the hypotenuse. So we know what the adjacent is, we know that's 1, but we don't know the hypotenuse, and we'll be able to get the hypotenuse using Pythagoras' theorem. So we have c squared is equal to a squared plus b squared. So c squared is the hypotenuse, which we don't know, which I might call x. So x squared is equal to 1 squared plus 4 squared. So we get x squared is equal to 1 plus 16. So x squared will be equal to 17. So x is going to be equal to the square root of 17. I'll just put this in here. So we're trying to get what cos of A is. We know that the adjacent is 1 and the hypotenuse is square root 17. So our answer for this one then is 1 over square root 17. Question 3.4 says that given that cos of x is equal to 1 over 7, write sine of x in the form 4 root a over b, where a and b are elements of n, remembering that n are our natural numbers, and natural numbers are our counting numbers. So again, the first thing we can do, I might just write out SOHCAHTOA. Then I'll just draw the triangle. I might draw it the other way just so you can see that it doesn't matter what way you have the right angle triangle. So for this one here, we're given cos, and we've given cos of x, and that's equal to 1 over 7. And we know that cos of x is equal to the adjacent over the hypotenuse. So in this one here, the adjacent is 1, the hypotenuse is 7. Now if we label x here, the opposite is going to be opposite x, which is OPP. The hypotenuse is opposite the right angle. And we know the hypotenuse is 7. And then we have the adjacent, the last one left. And the adjacent here is 1. The question is asking us to figure out what sine of x is. And we know that the sine of x is equal to the opposite over the hypotenuse. Now we have the hypotenuse, we know it's 7, but we don't know what the opposite is. So we have to get the opposite, and we'll be able to get that using Pythagoras' theorem. So c squared is equal to a squared plus b squared. So the hypotenuse is 7 squared is equal to 1 squared plus b squared, and I might label the opposite y, so it'll be plus y squared. 7 squared is 49 is equal to 1 squared, which is just 1, plus y squared. Then I'll just take 1 from both sides. So we'll get 48 is equal to y squared. So then we'll get y is equal to the square root of 48. If you put the square root of 48 into your calculator, you will get that y is equal to 4 root 3. So the opposite there is 4 root 3. Now, going back to originally what they asked us to do, so we wanted to figure out what sine of x is. We know that sine of x is equal to the opposite over the hypotenuse. The opposite here is 4 root 3, and that's over the hypotenuse, which we know is 7. Now, if you look back, it says it wants it in the form 4 square root a over b, where a and b are natural numbers or counting numbers. We have here that a is 3 and b is 7. They're both counting numbers, they're both natural numbers, so that is correct. Sometimes they will actually give you the triangle, which is really handy, so it just makes our lives a little bit easier. So question 3.5 is one like that. So it says, use the information given in the diagram to find sine of a, cos of a. Give your answer in surd form. So first thing I might do here is write out what SOHCAHTOA is. We need sine of a, and sine of a is equal to the opposite over the hypotenuse. And we also need the cos of a, and the cos of a is equal to the adjacent over the hypotenuse. So I'm going to go to the triangle now, I'm going to label it. So the side that's opposite a is the opposite, so that's 7. The side that's opposite the right angle is the hypotenuse, and the last one is the adjacent. Now we know for sine of a we need the opposite, which is 7, and we need the hypotenuse, which we don't have, and for cos we need the adjacent, which is 2, and the hypotenuse, which we don't have, so we need to figure out the hypotenuse. And we can do that using Pythagoras' theorem, which is c squared is equal to a squared plus b squared. So I might label the hypotenuse x, so this becomes x squared is equal to 2 squared plus 7 squared. So this will end up being x squared is equal to 2 squared, which is 4, plus 7 squared, which is 49. So 49 plus 4 will give us 53. So we'll get x squared is equal to 53. And then x is going to be equal to the square root of 53, which doesn't break down. It just stays as square root 53. Now I'm going to write this in here. So to go back, for sine of a, it's the opposite, which is 7 over root 53. And here we have the cos of A is equal to the adjacent, which is 2 over root 53. Now, as you can see here, it says to give your answer in surd form. So that just means leave it as a surd, and that's perfectly fine. You can also note that in these questions, nowhere has it asked us to find out what A is. It only wants us to figure out what sine of A and what cos of A is. We don't need to figure out what A is in this example. So if it doesn't tell you to do it, don't bother doing it. And that's the end of this video introducing you to sine, cos, and tan.